Good afternoon, ladies and gentlemen, and welcome to my talk, Practical Attacks Against Virtual Desktop Infrastructure Solutions. Now, we're going to be talking about mobile VDI solutions, learning a bit about the solutions. My name is Dan Koretsky. I've been working in security research for over 7 years, from PC to mobile, low level for all operating systems. My job at Lacoon is to both analyze malware and research things that are happening in the malware, and try to find, both in iOS and Android, things that can help us identify it and remove it from your devices to protect them. I also take a look at trends, things that are happening around the world, to understand what is happening and what are the things that we have to focus on next in order to solve the problems as they appear. Something worth mentioning, this talk is not about saying that VDI isn't worth its money. VDI is a good product. We will talk about the value that it does bring. We are going to talk about risks that come with using VDI, which you can mitigate once you are aware of them. You can quantify them, you can work with them, and you can work to remove them. So what we're going to talk about today is, first of all, what VDI is, what the mobile VDI solution is, just a small explanation of the concept itself. We're going to be talking about a few of the threats that are known in the world today and how they relate, the threats that are known in the mobile world today and how they relate to the VDI solution. And we're going to talk about working with these risks in order to make VDI safe again. So what is VDI? VDI, Virtual Desktop Infrastructure, is something that actually allows the user to have a remote desktop, a virtual desktop, on any kind of device that he is using in order to log in to the services of the corporation he's working at. So if you want to supply the client with an ability to work in our office, but without having a laptop or having a computer in the actual office, this is something we would use. Now, the vendors actually commercialize this as something that brings you 3 points of value. The first one is enablement. The user can use the device, any kind of device that he has, so long as he can log into the VDI solution, just put in his credentials and start using the corporate environment. The second thing that it allows us is data leakage prevention and handling the problem of lost devices, because mobile devices can be lost easier than laptops. So since no content is actually saved on the device, the user can just log in and use the information on the cloud. Everything is stored remotely. So nothing happens when a device is lost. And finally, something that the vendors talk about a lot is intrusion. That since the data is encrypted as it's going from the device to the cloud and back, there is actually no problem with the device being compromised or with something malicious happening on the device, because the data is encrypted. We're going to challenge that assumption. We're going to talk about it. Now, just an example of how the VDI architecture works, since we're going to be talking about the concept itself and not a certain solution. The VDI is usually built of a few things. From left to right, we have the user device, be it a smartphone, a tablet, or anything else. It connects to the network and security and access and control services, a server that receives the connection, checks the credentials are okay, that user is allowed to access the resources he wants to access. And then the user receives all of the services such as SAP, Epic, or anything else he wants to log into, email. Now, in the market today, we have 2 major VDI players. We have Citrix and we have VMware. We're not going to be talking about any one of them specifically, but the examples we're going to see are going to be touching both of them. Now, let's talk a bit about threats to mobile VDI solutions. The first threat is using an MRAT for its key logging capabilities. Now, MRATs today are pretty widespread. We're going to be talking about that in a moment. But first I want to show you just a small video I've made. Since I like extreme sports a bit, so I happen to be working sometimes this way. This is just me at my workplace. And what it looks like is this. Let's assume I'm just going into my phone, just going to type a few things into the web. After I type these things, I just want to use my VDI to do a bit of work. So I go into the Citrix client. This is just the demo client, something standard that's on the net. I just input the server address. I'm going to write the username. And I'm going to write the password. I think I actually made a mistake in the password there, so when I log in, it asks for the password again. I'm going to type the password. Just logging into the device. And now we're going to log in just immediately to VMware 2, just see their solution, entering the username, the password. Again, it's important to notice that what I'm doing here is I'm just logging into the standard services of the VDI applications. And this is a device that has an MRAT on it. And what happens next is I just have to open the standard web dashboard that my MRAT supplies. Just take a look. I just have a dashboard for the device. I can do anything I want with it, and there's a certain part of the dashboard called keylogger. Now you can see things that I've tagged before. It's this product sometimes works really slowly. It takes it up to a minute until it uploads every piece of data that it gathers from the device to the web. So we're just going to see, like, I have to refresh a few times. I have to wait a few minutes before I can actually see every single piece of data that I've just used on the device. In a moment. Now, as you can see, whatever I've typed in the web, in any of the applications, every single username, password, this is just the sexy part, of course, but as soon as I have these credentials, and a malicious attacker could do anything with these. He could log into the services, he could take any data out, he could essentially just reach any piece of data that you have in the VDI, he could reach it himself. Now, what actually happens there is that a mobile remote access Trojan, which is called an MRAT, actually has basic capabilities on the phone. It just gathers all kinds of data, and one of which is key logging. It just gathers any keys that you can press on the device. This causes these things to be sent back. Now, I've looked at a demo we've just looked at a demo that makes VDI look not very safe, assuming the device is compromised. But what's of interest is that this thing is pretty widespread. These are just recent high-profile examples of events that happened with sometimes government manufactured MRATs. A recent example that our company actually found, maybe you've even heard of it, is the XSSor malware. This was a malware attack that was used against the Hong Kong democracy protesters. It targeted both operating systems. You can read about it more in our blog. This is actually a small summary of the types of MRATs that there are. This is a market that is pretty thriving. On the left, we have government MRATs that cost between $300,000 and $12 million, which recently we had a small event in which one of them was hacked and became from $300,000. As of today, it actually costs nothing because you can go on the net and access the source code and use it yourself. There's the darknet MRATs, which are sometimes free, sometimes a few $100s. They just allow you to easily repackage an application and spread it out. And there's the surveillance as a service MRATs, which are starting to be pretty widespread because using this kind of one, we'll see in a moment just how easy it is to get one. Now, as I've talked, one of these MRATs was hacked. What we actually saw after it was hacked is that it is the same exact thing as all of the other products. The only difference is the government-backed ones are a bit more advanced in their infection capabilities. They can remotely infect the device using all kinds of public known vulnerabilities mostly. But as soon as they are on the device, they supply the same capabilities. Now, this is just, again, as I was saying, this is how easy it is to buy a surveillance product. These products usually commercialize themselves as being non-malicious, watching your kids, making sure they don't do something dangerous, but they can just as easily be used for any target. And it is as easy as buying your car. There are these kinds of charts that just show what is better, what is worse, each one, which features it has. Now, this is all just hand-waving. It's just saying this is dangerous, this can happen. Now, recent research that we've been doing in collaboration with a company called Checkpoint is to try to understand just how widespread this threat specifically is. What we did was to look at mobile devices that are communicating through corporate Wi-Fi access points connected to the Checkpoint firewall. We had about 3,200 corporate gateways of clients that actually chose to be a part of the Threat Cloud program, which supplies them advanced protection in response to actually working with their data. This is how it looks. We supplied our network signatures for about 20 or less MRAT products to the Checkpoint Threat Cloud, and what we got back was data on hits. This means we got back data only on phones that actually accessed one of these signatures. This is what we got. This was pretty astounding. It's going to be a bit hard to take, so I'm going to explain it a bit. We have about 3,200 corporate gateways in a total of 123 countries, 48 of which we found infections. About 500 gateways had infections. So we managed to get an estimate of how many Android devices we have in each gateway. So in total, we had about 600,000 Android devices, 4,500 infected devices, and 3,200 infected iOS devices, which is not less interesting. For gateways in which we had a device estimate, we had 220 gateways of that type, we actually had a total of 644 infected devices, which gave us about 1.2 devices in 1,000. You can see the figures here are figures per some of the countries you might know: Greece, Austria, Poland, the US. This means that for an organization with 1,000 devices, you'd have, in Greece, for example, you'd have about 4 devices that are infected with this kind of a product. And these are signatures only on the widespread surveillance commercial products. We're not talking about any of the other types. Now, one more thing we did is take a look at gateways that have a large amount of devices. Let's say you're a corporation with thousands of users. We found that for gateways with at least 2,000 devices, half of them had infections. This means that if you're a corporation with over 2,000 devices, in Europe it's even higher. If you're a corporation with 2,000 devices or more, there's a 50% chance you already have infections in your current mobile devices. 1 in every 3 infections in this part of the study, by the way, was iOS. So what this actually means is not very easy to understand. This means that if you have 5,000 devices, you have an average of 5 infected devices. That's just assuming you have just 0.1 infection rate of percentage. Now the real question is, what are the chances that our enterprises are actually at risk? If you're a 2,000 device enterprise or higher, you probably have about a 50% chance of already having devices that are compromised. Now, what we actually tried to look at is to look at both the solutions. These are the solutions we knew at that point, at least, that were the most widespread. This was the Citrix Cloud you've seen in the video, and Pivot 3's test drive for VMware. These are just 2 slightly different products. Both supply about the same capabilities. So what we did is actually take a look at them and see what kinds of threats are actually a risk to them. Now, we've talked about the MRAT, the demo you've seen. This was actually keylogging for data or authentication info. The product we've used in the demo was mSpy. And as I've told you in the study, we found that these specific products were pretty widespread all around the world in 50 different countries. This product costs about $50. This is how it looked like, as you've seen in the dashboard, just username, password, server address, anything else the user decided to type while he was working. But we noticed that keylogging creates a lot of noise. So we're going to take a look at other options too in a minute. Now, one more option for keylogging that you have, technologically, you have a few options to do it. One is to repackage a keyboard. I've seen it mentioned in other lectures here already that it was done on SwiftKey in 2013. Repackaging a keyboard is as easy as taking the package after it's ready and just adding a small amount of code of your own. Now, targeting a country is as easy as repackaging its language back. I don't know how many of you have heard, there's been a recent outbreak of a Russian malware called Photo Album. This malware was spreading itself simply by sending SMSs with a link to the application to all of the person's friends with a Russian text just saying, take a look at my photo album. And it got to every single country in which there were Russian-speaking communities, because people sent it to one another and people opened it. Another option is to just do a man-on-the-middle on the active input method, perhaps through the binder, perhaps using a permission, just adding bind input method to your application. This part is pretty complicated and requires elevated privileges. Another option is to just use the input manager service, which is a native process, hooking it at the input dispatcher, and just seeing all input events. This is something that works across all Android ROMs in the world. Now, another thread that we're going to talk about is grabbing credentials locally. Let's assume you don't want to stay on the device. Let's assume you don't have a commercial tracking product on the Android of the person you want to track. As I was saying, keylogging has its own problems. It creates noise. You have to look through a lot of data to actually see the credentials themselves appear. We actually checked what happens if we target the client itself to grab credentials. Now, again, we've looked at both clients, but this would be relevant to any kind of VDI client. What you can do is run a privilege elevation vulnerability. You can enable JDWP debugging on all the apps installed on the device. What you do next is connect as a debugger to the VDI client, and then you set a breakpoint just on a function that handles the connection itself and the credentials. Because at some point, the VDI client talks to the server and has to send the credentials, so they do appear locally on the user's device. This is how it looks like, if you can see the text. We just initialize the JDB. We create a stop in a certain long function name that is a function that is relevant. We hit the breakpoint. And when we hit the breakpoint, the first thing that happens when the debugger appears is it shows us the local function variables. As you can see, the top is the stop. Next, we hit the breakpoint. And at the bottom, you can see local variables, just variable names and their values. If we take a closer look, you can see this is just the username and password of someone logging into a VDI solution. Once you have these credentials, you can do anything the user can do. You have his authorization. Now, how do you do this? You have to ptrace the init process to dynamically change the debuggable property. Or you could just start the JDWP thread in the relevant process. If you just want to do it for one process, this might even be simpler. Now, possibilities to hook apps are various. JDWP is not the only option. It is actually a lot of work. But there are frameworks out there, Exposed, the CDS substrate, which as soon as you install this kind of a framework, they actually have ready-to-go APIs that allow you to hook functions inside applications. This is just a small jar that is injected into every process by Zygot to initiate hooking. You don't even have to change the application code at all. Assuming you have root privileges to install the framework, this framework can also be hidden, so the user wouldn't even see that it exists. Another option is screen scraping. Let's go to the basic thing. Let's assume we just have the device and we want to take a look at it and just get all the information. There are two options in standard screen scraping in the world. One is the clipboard access, and the second is just recording the screen. To access the clipboard, you would actually have to do something very complicated. You would have to know the foreground activity is right now VDI, and then just inject a couple of events called Control-A, Control-C. This is something that just copies the whole text in whatever the user was opening into the clipboard, and you immediately have access to it. This is how it looks. On the left, we can see the user just opened up an email. And on the right, we can see the whole email text in plain text taken outside just by sending a few events and extracting it. Now, another option is to just use screen recording. This is one of the tougher options because you actually have to look at the recording later in order to find the important data. Again, you have to monitor the current foreground activity, and you just start recording the screen once you decide that this is the point at which the user is using important data. Android 4.4 actually has a new screen recorder. It's pretty simple to use, but it was usable even earlier by accessing frame buffer directly. Now, there's a new property as of 4.2, I think, that is called surfaceView.setSecure, which applications could actually set in order to not allow their screens to be recorded. This is something practically no application sets today, because nobody knows there is a certain property of this type, and by default, this property is false. Now, the last threat we're going to be talking about is actually a threat against iOS. since we don't want to leave iOS out. This is just a man-in-the-middle attack. Let's get back to my extreme sports a bit. Now, here it's something even more crucial, because assuming you open a link to install just a profile to use a Wi-Fi, this is something that there is on iOS. You just install the profile. You want to use the Wi-Fi. You want to get the free Black Hat Wi-Fi. I know a lot of people here made mistakes with the long passwords. It was tough. So let's say you connected to this Wi-Fi. You just install the profile. Now, I'm not even going to put in a user and a password. I'm just going to click the VDI client, which has everything in its memory, and just let it connect. I just open it up. I open up a certain document I want to work on. I'm a big worker at some kind of an important company. Now, once I do that, what you can see at this simple web dashboard is that this is just the username and password of the device connecting right now to the VDI solution. This is not even a jailbroken iOS device. This is just a device that we sent a single spear phishing email to. He opened up the link. That's it. As you can see, this thing allows other capabilities that if you'd actually log into other services, we'll see everything you type, we'll see everything you do. Now, again, let's see how this actually works. The VDI solution actually communicates in an encrypted way. So what happens in the process is that the user supplies the VDI credentials, the server authorizes the user, gives him a list of services, and the user begins a VDI session with the service he chose. Now, what happens is once we supply the malicious profile, what happens is this whole communication goes through that malicious profile. The attacker sees every piece of data going through that communication. This means that sending an email to the user with this profile is enough for receiving all of the data going through that communication. As you can see here in the text, if you can see, I think it's a bit small, we actually get the username and password just directly when it's connecting. So other options that you can do once you've done the man-in-the-middle attack is duplicating the actual screen input stream to a separate machine. You can actually see anything the user sees. You can even simulate commands to the client or server. You could just take over the session. You could input and add things into the session dynamically. The user wouldn't even know you're there. So in conclusion, there's a certain point on which VDI depends on the integrity of the host system itself. It protects the data, and it probably even makes the fences a bit higher to make it just a bit tougher to extract the important and secret data of the corporation. But if the underlying device is compromised, it's important to understand that the VDI solution is compromised along with it, without a certain special effort. So what we have is this. VDI actually brings enablement. VDI actually solves the problem of lost device and data leakage prevention, since no data is actually stored on the device before and after a VDI session. But there is a small problem with the intrusion part. Now, assuming you do want to use VDI because it brings you a lot of value, it allows a lot of flexibility, you want to make this into this. And this is something that we do at our company. One of our products is actually meant to create a mobile security strategy for a corporation that has a product to create layers that would stop these threats from getting to the device. Now, what we do is three things, and you can understand why they actually relate to VDI. We detect anomalies in the device, in applications, and in the network communication. Once we see something that is suspicious, we can block it, we can protect against it. One more thing that we do is we, as you've seen, some of the threats I've talked about require running vulnerabilities. We can actually assess vulnerabilities on each device as we go on it in order to reduce the attack surface itself, to prevent the attacker from getting to the device in the first place. And finally, once we identify the threat, you can actually integrate to even VDI solutions and simply either block the access to the VDI services once you understand the device is compromised, or use one of other methods that we supply in order to mitigate that risk. Just a bit of thanks for the big research with Checkpoint that was made. These are some of the people that have helped us. And thank you. Any questions? Yes? If you look at our...
I want to go to the two vendors, to be fair.
Yeah, I understand.
One or the other, obviously.
That's a really good question. The question was asked about any of the containerization or the other solutions that deal with intrusion into the device. There is actually a lecture of ours in the previous Black Hat that was about containers, secure containers, and MDMs, and all kinds of different solutions, and how once again, as soon as the device is compromised, they are compromised with it. Any other questions?
I guess just building on that question, so if you've been using one of those containers, whether it's not or good or whatever, of those four threats that you put up, which of them wouldn't be able to take hold of?
In the case of a container, first of all, you'd have to look at each threat, because you'd have to take a look at what type of a container you're using. Each and every one of the products that you mentioned actually solves the problem in a certain different way. Essentially, a product like the MRAT, it would be just as relevant. We have actually, I didn't show it today, but we have demos on all kinds of containers and all kinds of products of that type, that they work just the same way, because the container, he encrypts the data inside a small box, but it's still on the device. As soon as the user actually accesses it, it is out in the open. You can access it. So most of these threats, they talked about credentials, but they can be used about containers just the same way, with small, slight changes to the technology itself. Any other questions? All right. Thank you.